अस्सलाम वालेकुम स्टूडेंट्स, आई होप आप सब ठीक होंगे। वालेकुम अस्सलाम।
वालेकुम अस्सलाम।
ये बताएं कि नॉमेनक्लेचर में कल की एग्जांपल्स के बाद कुछ समझने की जरूरत है। डू वी नीड टू गो विद एनी मोर एग्जांपल्स और आर यू गुड?
नहीं चाहिए एग्जांपल्स और।
व्हाट अबाउट गर्ल्स? आर वी गुड? गर्ल्स? आर एनी गर्ल्स हियर? Yeah, I can see the Nisha here, Zoha here, Zainab here, but I can't see any of them speaking. All right, considering it's good, what we are going to do that we're going to stop over here with nomenclature and we are going to move on to the next topic, that is isomerism of alkanes. All right, just give me a minute. Okay. I think this much bigger is readable from your end, right? Is it?
Yes, sir.
Yes, sir. Good. Let's get started. Isomerism, the system of naming of compounds, emphasizes the importance for structure. Molecules with same molecular formula can have different structures. The same number of atoms can be connected together in different ways, and this is known as isomerism. Isomerism can simply be defined as a method or a phenomenon in which a molecule has same molecular formula but different structural formula. Okay, that's what I'm going to write it over here. Isomerism is a phenomenon. Is a phenomenon in which a molecule has same molecular formula but different structural formula. Okay, I think this one doesn't give us the option of word draft. So writing over here, you might not be able to read the whole thing together. Well, isomerism is a phenomenon in which a molecule has same molecular formula but different structural formula. How can we give an example to make sure that you understand it? The example is given over here in the book, and we're going to pick the same example. The example has the molecular formula of C4H10, that is simply butane, and butane can easily be drawn in a way like this. Okay, just a second. You can simply pick up one carbon atom, keep connecting it to another like this. And another. Of course, if it's butane, it must have 4 carbon atoms like this. This is the structural formula for butane. Oh, sometimes it works pathetic.
सर स्ट्रक्चर फॉर्मूला हमें ड्रॉ करने के लिए भी आ सकते हैं?
बिल्कुल, और अभी हम उस पर भी आते हैं. Fine, this is butane. This is simple straight chain butane. Another example of C4H10 would be doing it like this. Just a second. Then the support. And this. Take a look at the formula on the top. It has 4 carbon atoms and 10 hydrogen atoms. And if you take a look at the formula at the bottom, it also has 4 carbon atoms and 10 hydrogen atoms. Take a second, count all of the atoms to make sure that I'm talking about the same formula as you do. Right? Is everyone on the same page with me? Both the formula, the number of carbon atoms are 4 and the number of hydrogen atoms are 10. But if you take a look, we call this one as butane. 1, 2, 3, 4 carbons of but and singly bonded ane. So butane. Take a look at this one. This is a straight longest chain, and there is a branch. A branch has 1 carbon atom, and it is present in position 2. So this would be 2-methyl propane. Okay, writing their names over here, this one would become butane, and if we write this name over here, it would be 2-methyl propane, right? So these would be the names. So they have different names, they have different structures. They, let me tell you, have different identities. Even then, they have different melting points, boiling points, and chemical properties. So having a formula, because here actually we're having a formula C4H10 for both of them, but their structures are different, the names are different, and actually they're entirely different molecules when it comes to that, with different sets of properties. This is known as isomerism. I mean, this phenomenon is known as isomerism. However, these two structures, butane and 2-methylpropane, we're going to use the word isomers. They are isomers for one another. Isomers are the structure which have the same molecular formula but different structural formula. This is isomerism of alkanes. Okay. Now, what kind of questions do we have to face for this topic, isomerism of alkanes, in exams? Isomerism of alkanes is a very important topic in exam, and if we pick up last 5 years paper, you won't see a single paper in which isomerism haven't been tested in either the paper 2 MCQ paper or paper 4 theory extended structured paper or the paper 6. They keep on testing the same thing because it's very important. How do they test it? Now, in case of isomers, what they usually ask you to do is to draw the structures. In order to draw two different structures from a molecular formula, there are a few points or steps you need to understand. Okay? So what I'm going to do is that I'm going to continue with the same word file, and we are going to go with the next topic, and that is drawing of isomers, or drawing the structures of isomers if molecular formula is given. Okay? So what I'm going to do is that I'm going to again open up the same page, nomenclature of alkanes, and we are going to start with next topic, isomerism of alkanes. This is going to be isomerism in alkanes, and in isomerism in alkanes, as I've told you previously, it's all about drawing the structures. To draw different isomers of an alkane if molecular formula is given, or if one of the isomers is drawn. That is the part of the question. One of the structure of one of the isomers is drawn as a part of the question, and you are supposed to draw one more isomer, two more isomers in that case. Usually, IGCSE is not asking for more than two structures recently. If I say recent, I'm talking about the past 5 years paper. So what if the formula is given and you need to do that on your own? For an example, let's say the next formula is actually C5H10. How are you going to work with it? So, do you have your copies and your pencils near you? And I'm asking that from each and every single one of you.
Yes,
Yes,
sir.
sir.
Everyone has a copy and a pen? I mean, something to write
Yes,
with
sir.
and a
Yes,
copy.
sir.
Okay,
Yes, sir.
what you're supposed to do, and do you have cell phones nearby so that you can take a picture and send it to me?
Yes,
Yes,
sir.
sir.
Okay, so let's start doing that. First of all, draw different structures for C5H10. Okay, and I'm going to quote the examples over here that it's not difficult for you. The first structure would be simply contain. Okay, and the second structure is something that you are going to come up with. Pentane deformed with one branch. Okay, would still be pentane, but it's deformed with one branch. So we're going to name it that. This is not the actual name. Pentane won't be its actual name. We're going to name it by the rules of nomenclature. Just like this one was butane, and then we disrupted the whole structure, took one carbon out of it, converted into a branch, and the whole structure was renamed from butane to methylpropane. And the same thing is going to happen with pentane. So try to draw at least two structures on your copy. Take a small picture. Make sure your picture is not big in MBs. A few KBs is good enough. Don't go with the high quality pictures. Try to just focus in the area you have drawn. No need to take the picture of the whole page and send it to me right away. I'm waiting.
सर पेंटीन क्या करना है?
Yeah, C5H10. Make sure your structure has 5 carbon atoms and 10 hydrogen atoms, and it's all singly bonded, as the name of alkane suggests. Go ahead. You can do the structures one by one. For example, if you know how to draw pentane first in the picture, and then go for the next one and try to draw the next structure. And when you think you're correct with the next structure, then you can again send me another picture.
सर
G.
सर अगर C5 है तो H12 नहीं होगा एग्जांपल में?
Sorry, C5H12. Sorry. Thank you. Instead of writing of an alkane, I wrote an alkene. Thank you for the correction. So that's over here. Change the examples. Let's go with pentane, and this is going to be C5H10. Oh, sorry, H12, right? That's Okay, does your structure of pentane resembles mine? Yes, class. Does your structure of pentane, the first one, resembles mine?
Yes, sir.
Yes, sir.
Yes, sir.
That's a question for everyone. So keep those yeses coming. If that
Yes, sir.
is similar, if that's not similar, you can simply say no, that's fine. Anyone can make a mistake. It's completely normal. Anyone with a different structure than pentane? Or than what I have drawn on the over here? Very good. How about the second one? You come up with the same kind of structure, 2-methylbutane? Did you?
Yes, sir.
Who else says yes to this one?
सर वो मैंने सर CH3 फिर OH के सर OH के ब्रांच नहीं बनाई, मैंने थर्ड में जाके ब्रांच बनाई है.
It means the same thing. That's correct, by the way. Second पे नहीं बनाई. Because
सर
आपका
मैंने भी
structure
थर्ड पे बनाई थी.
कोई नहीं, that's correct. Because if I invert this structure, it would be same as yours. So it's just a matter of perception. Whether you do it on second or you do it on third, you're actually correct. Because if you're going to name it, the name would be same as mine. The structure might not be same as mine, but the name should be. And if the name's same and you're correctly deriving its name, then actually both of our structures are similar. It's just a perception of right or left or top or bottom. And it doesn't matter. According to IUPAC conventions, the rules that I've given you for nomenclature, it doesn't matter. Who else has the same structure? 2-methylbutane. These are the 3 students that spoke to me. How about Zain? Zain, you there?
Yes, sir.
Okay, was your structure same as ours? I mean,
Yes, sir.
name. Okay, good. What about the rest
Yes,
of
sir.
you? Rafe, Vase?
सर मैंने
Yes, sir.
3 methyl butane लिख दिया सर.
Acha, yet structure same tha.
Yes, sir.
Okay, good. That's fine. What about Vase? What about Kabir? And the
Same.
rest of the girls? Okay, okay, Rafe? What about Kabir? Kabir, you might answer me in chat, that's fine. Whichever student and the mic is not working, it's always fine to come up with answers in chat. Okay, good. Right, so Kabir had the same structure. Okay, class, can you come up with a third structure in case of this pentane, C5H12? And let me tell you, you might need to come up with 2 branches this time. So try to deform pentane in such a way that you come up with 2 branches. Jesus, just a minute. And if you're using laptops through the chat system, you can send me your file. Try to send me your file, the picture of the file through chat. Can you do that?
सर अगर सर जैसे कि सर आपने वो पहले एग्जांपल थी सर उसमें से CH3 हमने सर नंबर ऑफ हाइड्रोजन सेम 12 करने हैं तो सर आपने उनमें से जो एक है उसमें CH को एक की हाइड्रोजन एटम से लिखा है तो सर ऐसे कर सकते हैं मतलब उसको भी चेंज कर दें मतलब 3 की जगह
वो
उसको
ऑटोमेटिकली चेंज हो जाएगा. And I'm talking about the center carbon over here. If you're on the same page with me in terms of imagination, yes, the center carbon will lose all of the hydrogen and will all be converted into bonds. Okay, I'm going to draw a structure over here. How about this one? The name for this structure is beyond the requirements of your syllabus, but still, I'm going to quote it for you. Don't try to go for how to name these because that's still beyond the requirements of your syllabus, way beyond the requirements of your syllabus, but still I'm going to quote it over here. How about this one? Take a look. Does it fall under the same definition of isomerism, having the same number of carbon and hydrogen atoms, but different formula structure? I mean, different structural formula.
Yes, sir.
Yes, because it has 5 carbon atoms, it has 12 hydrogen atoms, but this one has a structure different than the previous two, even a different name to prove it. So these three would be 3 isomers of pentane, the same ones which I have numbered in the word file as 1, 2, and 3. The first one is pentane. The second one in which pentane is deformed with one branch is actually 2-methylbutane. And the third one in which we are deforming it with 2 branches will become 2,2-dimethylpropane. Is it understandable for everyone? If you have questions, please ask. If not, then concluding it over here. That approves of word. Okay, so I'm going to put a couple of rules over here. Just a second, it's the last rule I'm going with. Okay, we are actually working on the first rule. Now, imagine this. There comes a question in exam in which the first structure of this C5H12 pentane is given as a part of question. And he asks you to draw uh, another isomer for this structure, which is a common question in past paper. For butane, for pentane, the drawing of an isomer is a common past paper question. So what we are doing over here is that we are already acting upon the rule number 1. Take a look. If the structure is a straight chain, this pentane is a straight chain structure. It has only one chain. It has no branches. If the structure has no branches, it is known as a straight chain structure. Then you can convert it into a branch chain structure, right? So if we convert this pentane into 2-methylbutane, we made an isomer of the structure. Or vice versa, if he gives you 2-methylbutane as a part of a question, which is a branch chain structure, has one branch, you can convert it into a straight chain structure as an answer to your question. Do you get my point? And this question is for the whole class. Do you get my point? If anyone's confused, please ask. I can repeat it. If you get the point, very good. Yes, class. I need a solid yes or no from every student in this question. This is very important. Let me tell you, you won't find a paper in which isomerism is not one of the questions, especially paper 4.
Yes, sir. और आगे sir.
समझ आ गया. Okay, good. ये yes कौन कह रहा है इस वक्त?
So वासे.
वासे. अच्छा, कबीर को भी समझ आ गया, वासे को भी समझ आ गया. What about the rest of the students?
Yes, sir. आ गई.
Okay,
Yes,
good.
sir.
Okay.
Yes,
sir.
sir.
Okay. So starting with Vase. Vase, can you explain the same thing I just explained to the rest of the class? They can hear you.
Sir के
मैं rule number 1 में क्या कह रहा हूँ ये explain कर दें बस. ठीक है?
सर अगर स्ट्रक्चर स्ट्रेट चेन है उसका कोई ब्रांच नहीं है तो सर उसकी हम सर यानी ब्रांच बना देंगे और अगर उसकी ब्रांच दी हुई है तो फिर हम उसे यानी स्ट्रेट चेन के अंदर कन्वर्ट कर देंगे.
Okay, good, good. That is कि वो आपको आइसोमर की स्ट्रक्चर ड्रॉ करने का क्वेश्चन देता है. ठीक है? पॉइंट नंबर 2 में अभी एक्चुअली हमने फंक्शनल ग्रुप डिफाइन नहीं किया तो पॉइंट नंबर 2 में अभी नहीं कर रहा. We'll pick up point number 2 some other time. हम उसे फंक्शनल ग्रुप के साथ करेंगे, but a little later, not yet. ठीक? So are we clear with this example? I mean, rule number 1. If we are clear, then keep that in mind that it's not important that you always come up with a structure that only consists of one branch. You may convert it into a structure with 2 branches, 3 branches, 4 branches. Those 2, 3, 4 branches can be on the second carbon, on the third carbon. They can be 2 branches on 1 carbon. They can be only 1 branch on 1 carbon. Take a look. All of this is explained in these examples. Take a look. This carbon actually has only 1 branch. But in case of this carbon, this has 2 branches, one on top, one on bottom. So there can be more branches. Okay? There can be a structure which only has 1 branch in the entire structure. There can be a structure which has 2 branches. Those branches can be on different carbon atoms. Those branches can be on same carbon atoms. Clear? I would like to also clear one very important point over here. Okay? और class इस point को अच्छी तरह से समझ लें, otherwise you'll be making a lot of mistakes. In alkanes, okay, or in alkenes or in hydrocarbons as a whole, you cannot draw a branch on the terminal or corner carbon. Terminal carbon पे या corner carbon पे branch नहीं हो सकती. ठीक है? और से देखें. For example, ये pentane है. टर्मिनल कार्बन्स वो होते हैं जिनमें यूजुअली आपके पास CH3 होता है अल्केन्स में. एक ये CH3 वाला है, ये कॉर्नर पे है, और एक ये कॉर्नर पे है, ये CH3 वाला है. यहाँ पर अगर एक और कार्बन लग जाएगा तो वो ब्रांच कभी नहीं कंसिडर होगा. वो एक्चुअली इस स्ट्रेट लाइन का स्ट्रक्चर ही में काउंट हो जाएगा, वो पेरेंट चेन में काउंट हो जाएगा, वो ब्रांच का पार्ट कभी नहीं बनेगा। ठीक, इसी तरह से 2 मिथाइल ब्यूटेन को गौर से देखें, इस स्ट्रक्चर में हमारे पास 3 CH3 पोर्शंस हैं, एक ये वाला कॉर्नर कार्बन है लेफ्ट हैंड साइड, एक ये वाला कॉर्नर कार्बन है राइट हैंड साइड, और एक बॉटम पे कॉर्नर कार्बन है। ठीक है, तो हमारे पास 3 कॉर्नर कार्बन है। अगर इस केस में किसी भी कार्बन के ऊपर एक्सटेंशन आती है, एक और हम कार्बन लगा देते हैं इसके ऊपर, खुद से लगा देते हैं, तो दैट विल नॉट बिकम अ पार्ट ऑफ ब्रांच। ठीक है, वो ब्रांच का पार्ट नहीं बनेगा, नहीं, यानी नई ब्रांच नहीं बनेगा। किसी प्रीवियस ब्रांच का पार्ट हो तो अंडरस्टैंडेबल, ठीक है, जैसे यहाँ पर हम कार्बन लगाते हैं, इट मे बिकम, मे और मे नॉट बिकम अ पार्ट ऑफ प्रीवियस ब्रांच, लेकिन वो नई ब्रांच के तौर पे नहीं आ सकता। ठीक है, इसी तरह सेम इज द केस विद द लास्ट स्ट्रक्चर। लास्ट स्ट्रक्चर को गौर से देखें, इसमें हमारे पास 4 कॉर्नर्स हैं and there are 4 CH3 entities in there, the one at top, the one at bottom, the one on the right, the one on the left। ठीक है, इसमें से कहीं पर भी हम एक्सटेंड करते हैं और CH3 को आगे एक्सटेंड करके उसके आगे एक और कार्बन लगाते हैं, टॉप बॉटम राइट लेफ्ट, तो वो न्यू ब्रांच नहीं बनेगा। ठीक है, so let me tell you कि you cannot make a new branch on the terminal carbon or corner carbon। ठीक है, terminal carbon is the actual term that we use in organic chemistry, corner carbon is just you can say a childish term to explain yourself। ठीक, so a branch can never be on the terminal carbon, it has to be in one of the center carbons। तो अब 2 मिथाइल ब्यूटेन का स्ट्रक्चर बनाते वक्त कुछ स्टूडेंट्स ने मेरी तरह लेफ्ट साइड से सेकंड पे बनाया था, कुछ स्टूडेंट्स ऐसे ने राइट साइड से सेकंड पे बना दिया, यानी लेफ्ट से थर्ड पे, तो दैट्स फाइन, that's just a matter of perception। Some people see it from the left hand side, some people tend to see it from the right hand side, or from top or from bottom, it's just a matter of perception। In that case, the name won't change, the structure won't change, according to our rules it is the same entity, same molecule, it's not even a different isomer, it's the same thing। See, so I hope you all understand this fact that you cannot draw a new branch on any of the corner carbons। Are we all on the same page?
Yes, sir.
Good,
Yes, sir.
good। Okay, this means that you are now good with isomers। So what I'm going to do is that I'm going to give you a small piece of homework. We are hardly left with 2-3 minutes, so I'm going to give you a homework. Keep your pages in front of you. I'm going to draw some structures, quickly draw them on your copy, and then solve the question as I gave you. Okay, just a minute। जी, and this is hexane। Please draw the structure of hexane on your copies quickly। And you're supposed to draw me 3 different isomers of hexane। Hexane is actually C6H14। Please write it over there. It's C6H14, hexane। It's C6H14। Okay? That was the first question. Hexane C6H14 with the following structure, you're supposed to draw 3 isomers। This is the first one. You cannot take it as an isomer. You're supposed to separately draw 3 isomers। Question number 2. Molecular formula is C7H16। Molecular formula is C7H16। You're supposed to draw 4 isomers। And for question number 2, even a straight chain structure would be considered as an isomer। तो उसमें आपको ये लीनियंसी हो जाती है, if you don't have any structure, तो जो सबसे पहला स्ट्रक्चर आपके ज़हन में भी आएगा, the simplest one, the straight chain one, that will also be a part of an example। ठीक? Are we all clear? So you have hexane
Yes, sir.
C6H14. You have already a straight chain structure. You're supposed to draw 3 more isomers. The second example is C7H16. And for that case, you're supposed to draw 4 isomers. And none of the structures are given, so you can draw structures as you wish. So tomorrow, before class, you're supposed to send me that book. Okay? Either you send it through chat or you send it through WhatsApp. That's fine by me. If you're going to send it through WhatsApp, don't send it into the group. Send it to me individually. Okay? Make sure you take my number from the group. Okay? All right, class. There are only a few seconds left. Take care. Allah Hafiz.
Allah Hafiz.
Allah Hafiz.